Starting here on the right, Jason Denning with Upsight. We're going to do introductions, but really cool, interesting company with Upsight. Christian Beedgen with Sumo Logic, CTO. Matthew Williams with consultant to Flowroute, and our own Mike Place, who's a platform engineer. So with that, why don't we just start with Jason and go down the row, take about 3 minutes to introduce yourself, your thoughts on EDI, well, one sentence on EDI maybe, and your interaction with Salt.
Yeah, I'm Jason Denning. I work for Upsight. We do mobile. We do analytics and segmentation marketing tools for mobile apps. If you've ever played a game on your phone, you've likely hit our API. I've been using Salt for about 3 years now. I'm SaltStack certified engineer number 2. I'm also an AWS certified architect. Yeah, with EDI, it's kind of, I think that's the wave of the future. It's definitely what I spend a lot of my time sort of daydreaming about, cool things that I want to do. So.
Cool. My name is Christian. I started together with my buddy Kumar Sumo Logic back in 2010. We've been around for 5 years now. We do log management as a service. So just to make it really simple, you know what Splunk does, you know what Elasticsearch Logstash and Kibana does. We do all of that plus a bunch more, which I'll be happy to talk about outside. And the big thing about us is that we are a service, so you don't have to actually go and set up even more machines and figure out how to run all of them and scale them, etc. So it's just a service. You just basically get, to use the application. So we think that's pretty cool. As far as EDI is concerned, or actually let's start with as far as Salt is concerned. I'm the odd guy out here. I'm actually not a Salt user. So what the hell am I doing on this panel? We are starting to work with the Salt guys, and we're starting to work on some cool integrations. We do log management. We can provide. We're looking forward to be able to provide sort of end-to-end integrations, visibility into what's going on the masters and the minions, etc. So, as far as EDI is concerned, I like the idea. I like the idea of messages flying around, events flying around. In many ways, Sumo Logic is a system that does, a lot of that. If you just equate messages and events with logs, we have a real-time processing engine. We can do alerts, all of those kinds of things. But interestingly enough, the way that we run the service today ourselves is we're basically doing a human-driven infrastructure to some degree. We automate all the deployment, but event management, etc., still goes through a sort of playbook process, and there's still humans involved and so forth. And I have some ideas of how we can improve on that, and we'll get to that a little bit later.
I'm Matthew Williams, a consultant to Flowroute. At Flowroute, we are a voice over IP provider, telecommunications carrier. We're one of the fastest growing telecommunications providers, in fact, in the voice over IP industry, growing very quickly year over year. We've been using Salt for a couple years, in production for about a year. EDI is big for us going forward. We're in the process of engineering going into the cloud, and as we do that, Salt's going to definitely play a very important role.
I'm Mike Place. I am cached out on GitHub, so I've been lucky to meet many of you either via the GitHub issue tracker or through our community or here at this conference today. As most of you know, I am one of the elusive people who get paid to write open source software, and that's wonderful for me, and I feel very lucky to be able to do that. I work on Salt full time. I focus my work generally around the core, around the event system, and I feel very, very strongly about event-driven infrastructure as some of the future of IT, and I think you'll see that much of the work that we've been doing in Salt over the past few months, and some of the work that we'll be unveiling that you'll get to see in the next few months, is very, very heavily focused around this idea.
Okay, so we've got another 40 minutes here, And I want to make it interactive. We have a few questions for the panel here, but as there's a lot of content that we've already discussed. But let's dive right in of use cases. So use cases for EDI. And Jason, with your, at Upsight, your use case for, or your implementation of EDI.
Well, I'd start by saying that we're not using EDI as much as I'd like currently. I think that most people encounter EDI as some variant of auto-scaling. That's probably the obvious use case. You know, your metrics start ramping up beyond acceptable levels, so you want to provide more resources to your stack. I think that there's a lot of potential to expand on that and use EDI for all sorts of things. If you really think about what we're talking about with event-driven infrastructure, an event is anything that happens that you can define and has a timestamp, basically. So I've thought about use cases along the lines of, say your company gets a mention in a tech publication or something, or you get a big Twitter storm of tweets about some product you release. That might be an event that you want to make some changes to your infrastructure on. Might be auto-scaling. I think there's a lot of use cases for self-healing infrastructures based on events. I think, I mean, anybody who's using Salt is using EDI to some extent because that's basically how the Salt infrastructure works. You send an event through the message bus and magic happens on the minion side. We are currently using Reactor for a variety of deployment use cases. I'd like to start using EDI for more blue-green deployments. I think that'd be a really good way to go. So we deploy a new version of our app out to green servers and trigger the load balancer to give it a very limited amount of traffic. And then as we see that everything is working okay, then the blue server transitions over and the load balancers adjust accordingly. Or if there's problems, you roll back. I think that's probably the next place I'd like to go, is being able to do rollbacks based on events.
Yeah, so in a high level for me, it's really about, you know, turning this whole thing into a closed loop system, right? Where you got the infrastructure engine, you know, like Salt, for example, it's able to, you know, stand up whatever you need to stand up. So in our case, I already said that we don't use Salt. We started in 2010. We didn't really want to take anything off the shelf. We didn't feel like anything was mature enough. You know, NIH, of course, happens. We rolled our own. It's all model-based, so, you know, we have a custom model, basically, of how a Sumo deployment looks like. And, you know, I'm just throwing this in there, sort of, you know, the idea of having a model or sort of a desired state. This kind of, I think this is what a lot of configuration management is about. The model is usually something static, so you basically express it somehow. You know, states or whatever it is, depending on the tool you're using. In our case, it's XML because it was 2010. And then you say, make it so, and then it makes it so, you know, and now your stuff is there and it's running, and now you have a runtime concern where, you know, your configuration is not necessarily static at that point anymore. I mean, in reality, there is a very dynamic, you know, aspect to it, and so the question is, that dynamic aspect, how do you manage that? And ideally, you would have to some sort of tool, some sort of combination of things that can, based on, you know, information, decide that things are changing, you know, trigger auto-scaling, these kinds of things. But, you know, just on a higher level, sort of, you know, close the loop and go back to the infrastructure engine and say, hey, you know, update the model and then make it so again, right? And, you know, we think that a tool like Sumo, for example, and that's what we're kind of experimenting with internally as well, gets a lot of information, you know, all the logs from the applications, infrastructure, services, you know, OSs, et cetera. And, you know, given that we have a correlation and alert engine, you know, our preference is to sort of express sort of the event triggering logic, you know, in our system, just because we have so much data to make, we think, educated decisions. And then, you know, then you hand it back off to the infrastructure engine, and then the infrastructure engine can react to that. And the question is, how do you do that, right? Do you have a model behind the scenes where you can then update, where you have an instance of the model for this particular runtime, and you can update parameters, and then again you just say make it so, or then do you go and, you know, quote unquote just SSH and do something? That's something that, I honestly don't know what the right thing is to do. I'm hoping that there's probably going to be some input, coming from you guys as well.
Matthew, before you start, I see a lot of faces in the crowd that are managing some very complex infrastructures. So by the time we get to Mike, we'd love to hear some thoughts or questions from you guys to the panelists with that.
So I'm with Jason in that we're not doing a lot of event-driven infrastructure yet, but we have plans for it. I wound up on this panel because I did some work, early work on monitoring with Salt. Not using Salt to manage monitoring, but actually using Salt to do the monitoring. I hope I'll have an opportunity to go into a little bit more depth into how that was done. I'm not sure if right now is the moment for that. Yeah. So, on a deeper level, what made this possible with Salt is its plug-in architecture. Salt is incredibly pluggable. You can customize just about everything it does, and in the Salt monitoring prototype that I worked on with help of several other input from several people at SaltStack, we used maybe 5 of these pluggable modules, starting with execution modules, which did the heavy lifting of actually identifying problems or lack of problems. A special type of state module or plugin that instead of enforcing a state, identified a state, and either passed or failed the state based on whether it's in the expected condition. Next, we used returner modules to feed that information as events back to the master. The master used a reactor, and to trigger runners, which close the loop by, if not needed, processing the events and triggering alerts via execution modules. So that's how I wound up on this panel, and going forward, I'm looking forward to being very involved in event-driven architecture infrastructure as we move into the cloud, like I mentioned before.
Yeah. So I think in addition to thinking about use cases, I think event-driven infrastructure addresses some of the mistakes that we've made in the past 10 or 15 or 20 years, and there are a few in particular. I think as we start to build out complex infrastructures, one of the things we run into is we run into silos, right? We have monitoring silos, right? And we have stacks, right? We have application stacks, we have OS stacks, we have all of this stuff. But as we've begun to build up vertically, and as we've begun to silo, what we've done is every time we want to communicate between these types of silos, right, we've designed, single point APIs, right? So you want to get information out of your monitoring system, well, you go ask your monitoring system, right, and it gives you information back. That model is, I think, really hard to scale. I think it's really hard to manage, and I think one of the fundamental things that it lacks is it makes it extremely difficult to create systems which have a shared stateful awareness, right, about the health and activity of a given network. And I think that's one of the ceilings that we're starting to reach in modern IT. And so I think that instead of thinking about use cases, I think it's a little bit better to think about some of the things that we've broken and how we can fix them. So that's one. Secondarily, I think that event-driven infrastructure gives us the opportunity to address some shortcomings in the way in which we've sort of demoted certain parts of our system, our systems that we've built. One of the things that we've done, right, is that it's hard to make everything on our network a first-class citizen because there is no singular, universal, high-speed event bus, right, that's fast enough and pervasive enough to allow all of our systems to communicate and share state with each other, right? I think event-driven infrastructure allows you to make your monitoring system a first-class participant and to react to and put events on that bus in the same way that your proc file system could emit kernel events, right? And so what's been so hard in the past is we've had to spend all of this time and effort trying to glue these pieces together to solve individual use cases, right? But I think trying to bring everything onto a singular playing field, we can take those complex systems and we can actually start to reason about and build truly reactive, autonomous, healthy systems.
So with that, questions from the audience? Ken.
Do I have to use a microphone?
Yes.
So I sat through the reactor and beacon sessions, and my imagination's kind of on fire now, what this means for environment. But I'm kind of taken back to a time long ago when I started doing event-driven programming. And, your environment becomes a lot more dynamic, your code paths are a lot less linear, and you start running into these very weird interactions. Do you guys have any horror stories, best practices, design patterns? I imagine this world where I'm troubleshooting a server and an event fires and suddenly, that cluster gets pruned down and my server goes away. I see you guys are laughing, so I'm hoping you have a good story.
Christian?
Well, so I don't necessarily have a concrete story, but I have a couple of thoughts on that aspect of auto remediation. I mean, this is anyways a term that I've heard before. I in a prior life I was at this company called ArcSight where we were doing security information event management. Again, all the logs go into one place and you make decisions, and then, hey, oh my God, I have a bad guy in my network. So then the idea would be to remediate, right, and go, and kick that sucker off, right? And we've been trying to sell that, in the last decade. We even acquired a little company that was making that easier by doing network policy management and all these things. And what I found was that there's a huge amount of skepticism on the user's end to actually turn these things into auto mode, right? And so what I'll offer is kind of a basic classification. I think, ultimately, you can react in fully automated mode, right? I mean, that's clearly where you want to go, right? If you do that, I think it'll be extremely important that you, that you document basically, what is happening, and given my background, it's not surprising that I'll say, just log it, right? And so that you have that record, and then you can play with it later, and then you can kind of trace what happened, and that goes back to that event-driven programming thing, because that is hard. It is really hard. It's much harder than multi-threaded programming, because it's very hard to figure out the control flows, right? Well, multi-threaded programming, there's obviously other traps, right? So having said that, so the second thing then is sort of what I'm thinking about is sort of kind of a semi-automated remediation where you say, hey, before I'm actually doing that action, I have some sort of dialogue with the user. I'm telling them I want to do this. Is it okay? Or maybe you can give them even depending on how well it's authored, you can give them a multiple choice thing. And then I think there it's really important that you document to the user how you got to that state. So whatever the event triggering machinery can include in terms of context, even if it probably actually has to go and fetch that context first, maybe that is the first step. That can be automated as well. It's like I'm running out of disk space. Okay, so here's the top 10 biggest files on the disk, right? So you don't have to go into that yourself. I mean, all of that kind of bundling up. Then let the user make a decision. Then of course document all of that again. And then number 3, simply it's just not going to be automatic, right? It is manual, but you can still trigger that workflow. And again, you can bring all of the information in that, that based on some sort of playbook logic that you have, you would expect all the steps in your playbook that it says when you get that alert, do X, Y, and Z, and then figure out what the hell to do. Again, the infrastructure engine can potentially just do that for you, right, and put it somewhere. And then as a human, you can make a much better informed decision. Anyway, so those 3 steps, I think, and the semi thing in the middle is kind of interesting. Actually, the semi thing is interesting because I think that's how you probably get to people. My hunch is that that's the easiest way to get to folks.
Jason?
It seems like a logical step to have somebody first be offered the action and then execute it by hand, and then once you gain confidence with it, then allow it to run in a fully automated mode. That's a great point.
Totally. I think automation is always a dangerous thing, right? You're setting some sort of algorithm loose to make decisions on your behalf. So it's really imperative that you understand, all of the automation steps you're taking. But I think a good analogy here is anybody here doing continuous delivery? So how do you prevent a bad code push from destroying your whole app, right? It's testing. And I think that's really a critical component of this. The more automation you do, and this is another thing that I'm really passionate about working on is test-driven infrastructure and having these infrastructural tests that, are kind of watching your back for this sort of stuff. And also, I'd like to point out, with regards to your use case you pointed out, your problem case, say you're working on something and a whole stack of servers goes down. Well, I would consider that an event that should be reacted upon, right, as the result of a test failing. That, okay, I need these app stacks up, and they're not there anymore. So you should have some sort of way to bring up a new app stack. And I also think it's real similar to, let me say, the first time I encountered NoSQL databases, I was very skeptical because I saw a lot of people treating these as schema-less, easy to use, like, oh, I don't have to think about my schema at all. But in practice, if you look at people who are doing NoSQL well, they're thinking more about their schema than people are with relational databases. And I think it's the same sort of thing, that if you want to do these event-driven infrastructures, you've really got to think about it. You've got to think about what events are happening that you care about, what actions you need to take based on these events.
I think it's also really easy to overthink or to get really focused on some of the problems, right? I mean, one of the things that event-driven infrastructure enables is something as similar as what would be analogous to a callback, right, in programming, right? It enables asynchronous behavior on infrastructures, which I think is an extremely important point to think about, right? Because we have, deployment paths, right? We have remediation paths, all of which can benefit from, that very simple model. And so, we don't have to build complex decision engines, and maybe we shouldn't, quite frankly, right? We can utilize this on a very, very basic level to solve a number of low-hanging fruit problems before we get into too much autonomy.
Matthew, any thoughts?
Not too many on this. I think the others have reiterated that you just better be really careful before you set this stuff loose. So that's really all I got to say.
Thank you. Other questions? Seth.
This question's possibly specific to Matthew, but I was wondering what is the state of monitoring style modules in Salt? What's gone into core, and what do you think is still outstanding? What would you like to see added from here, or any other build out? Not in module land, but say with the reactor. Obviously, beacons will be big for this, but what do you think is outstanding, and what's the current status of those?
Yes, so I have to admit that it's been a couple months since I've been able to work on salt monitoring. So I'm not 100% sure whether there's been anything done since I had to drop the work. At the time, there were not very many salt monitoring states. The focus was on getting the overall system working. well. With the advent of beacons and engines as well, the new engine plugin is going to change the way that monitoring could work. Greatly simplified it. Could greatly simplify it, and I hope that I'll have the opportunity soon to jump back into this. And but it's to answer the question, it's pretty far, I think, from being ready for general consumption.
Are there any specific kinds of modules you think are low-hanging fruit or high priority that should go in?
Not sure about that, actually.
If I could just tag on to that, I was very suspicious of the new rate system until yesterday when I listened to Thomas talk about it, and now I'm so pumped about it. It really has the potential to make a lot of monitoring tasks possible with Salt that just aren't realistic over the ZMQ bus. Full disclaimer, I haven't actually used it, and the IO flow stuff looks a little Fortran-y to me, but that, it is what it is. But it has a lot of potential for being able to shove a lot more events out across your stack in a much more reliable way than is currently possible.
So I have one more comment on monitoring since we're on that topic, which is a challenge that that I think all monitoring systems have is high availability. How do you make sure your monitoring system is monitoring? And yesterday Tom mentioned clustering of masters, and I think that's going to be the answer.
Other questions?
This is partially directed at Christian, but I'm sure Matthew will appreciate some of this as well. Christian, you mentioned that you work with, for example, Elasticsearch and Splunk, and those are topics that resonate with me as an admin. For me, an event can be something as small as just a mathematical, like a delta, because in the server administration world, we're looking at information about CPU, memory, disk. Do you think that there's room for improvement in Salt and other solutions for dealing with that math at the minion level, distributing that work? Because I'm sure you can be aware that concentrating metric information about hundreds or thousands of minions on one or even a small cluster of masters is daunting to the master.
Yeah, so my response would be to just instrument the minions to send the metrics to Sumo. There's really not much. I mean, that is basically our business model. We have, so our monitoring system, happens to be very highly clustered, and, running on thousands of instances and all of those kinds of things. So, our collector, even if you use the HTTP API, if you don't want to use the collector, supports compression. So, classic sort of issues like network bandwidth, et cetera, just don't really matter. We've seen it. I mean, we have folks are sending us on the order of about 10 terabytes of data per day. So that does work, right? And then, the idea is that you get it into one place, and then you can essentially do whatever you want with it. So that's kind of the stance that I have.
Matthew, do you have any thoughts on that?
Yeah. So the question had to do with distributing the effort to the minions, and am I correct to understand that your question is not about minions analyzing their own data, but having a set of it is. In that regard, I think that there are any number of ways it could easily be done. As far as the minions doing their own analysis, that could be something running on a schedule or a minion side engine continuously analyzing data.
So like done. encapsulating something like Collect D or so.
Matthew would like to tell you all about that.
Yes, so after Tom showed us the engines yesterday in the session, I was having difficulty sleeping this morning. So early in the morning, I thought, it'd be handy to have engines on the minion. So I went and looked at it, and 3 lines of code in minion.flow, and a line or 2 in minion.py. And for rate-backed, if you're using rate, there are now engines in the minion.
I was going to say, I think that entire pull request is 6 lines, if I remember right.
Yeah, that's about right. Yeah, I don't have a business card on me, but yeah. All right.
Good question. What other questions? Mike, do you have anything to add to that last one?
Yeah. So I mean, I'm really happy actually about Matthew's contribution from last night in terms of minion side engines. And I think that that question of distributing work is going to be very, very interesting, and I think there's a high likelihood that that we're going to start to look at that area. I think sort of tangentially, one of the things that EDI tends to make me think about is that I think we have a lot of lessons to learn from the distributed computing folks who have been solving these problems for a long time. And I think we have not paid enough attention to the work and the research that's been done in that area. And one of the points of advocacy that I try to make is that we should look to them to try and figure out what they've done to solve those problems in HPC, in distributed computing, and try to bring those answers back into commoditized mainstream IT infrastructure. Right, and as I'm sure you know, we do a lot of work on that in Salt, we can't bend the laws of physics, but if we can't make it asynchronous, we don't build it. Yeah.
I was just curious if you guys had any recommendations on where an organization would start, maybe the optimal way to free up resources. Is there anything you've seen in your working so far? And I guess both people and or hardware, right? If we could start one project today and free up a lot of time for the guys in operations, what would you guys suggest?
If you happen to be using AWS, I think that that's a really good place to start. Start using CloudFormation more. And one thing I've really liked to do is to take the events that CloudFormation emits as it builds resources and plug those into Salt. So I can do things like auto-accept keys or run high states on particular hosts while they're coming up. I think the Salt reactor is a really good place to start. Like if you just run, if you look in the tests directory in the Salt Git repo, there's like I think it's called listen_event.py that will just start, if you run it on the master, it'll just start printing out all the events that go through. And if you look at what Salt's doing, you'll see that there's just hundreds and hundreds of these events, which will start giving you ideas of good places to hook in. I think that's probably low-hanging fruit, and start using the reactor. It's easy. I mean, you can do amazing things with 10 lines of code.
A lot of people start with their continuous deployment process is where we see a lot of early traction because the problems just tend to align themselves really well with these sorts of solutions.
Yeah, putting in a hook to your Git repo to start doing stuff, that's another good, easy thing to do. Low-hanging fruit, I agree.
So what about starting in an organization that's got some aging Snowflake servers that you can't move off right away? What might be a good way to integrate those? Maybe if the version of Python might be too old for Salt or anything, is there any kind of high-level things you can think of to at least get some of those old servers participating in some form?
I think the first thing to say about that is that I would very, very much welcome basically multiple language libraries that can essentially emulate beacons, right? That can put events onto the Salt event bus. I don't think you need Python or Salt or frankly ZeroMQ to do any of that. I think we ought to be able to build lightweight language libraries that accomplish those tasks. And if there are people in here who are interested in that problem, I would very much like to talk to them.
Yeah, and along those same lines, if you don't mind a little bit of a latency hit, you can always set up some other sort of message queue or event bus somewhere else in your infrastructure, like as a service. Like you could use, SQS if you're on Amazon. If you're masochistic, you could set up some RabbitMQ clusters, various things like that, and use web APIs to start pumping out things that you care about. Yeah, I think there's a lot of room for modularization. I really think probably maybe next week I'm going to try to do a minion side engine that just listens for like various webhook type calls for integrating this sort of stuff.
So if you're stuck with this hardware for a really long time, it might be an interesting thing to look at proxy minions, which allow you to address devices that cannot run Salt as if they were running Salt. Still up to you to figure out how to get the messages to and from those systems. But if you have a way to do that, then you can at least tie it into Salt that way.
Yeah, virtual ENV on legacy Python. Might want to look at that so you can run a current version with an old version while you transition.
Yeah, I mean, in my last job, we totally got Salt running on like Solaris 9 or something like that. So it's doable.
So one of the things I'm curious about is just scalability. So assume I go back to the office tonight and we love it and we like start throwing every event we can think of on it and we're pushing like 40,000 events per second through Salt. Where do you guys foresee bottlenecks occurring, right?
On the master.
Yeah, I mean, I think that's a big part of the motivation for SaltStack, and correct me if I'm wrong, but I think that's a big part of the motivation for building the rate system is to get rid of the sort of ZMQ bottleneck. ZMQ wants to open up all these file handles, whereas the rate system doesn't. So it's much lower footprint.
Do you guys have any experience with like practical limits that we should keep in mind when we're implementing this ourselves?
Just running on my laptop.
Yeah, I mean,
this running scheduled monitoring runs across a couple LXCs on a frequent basis was enough to get the Salt master pretty hot.
Yeah, it really depends on what kind of hardware you're throwing at it. I mean, some people out there have some really beefy Salt masters that are supporting a number of minions that seems insane to me to do on a single master, but people are doing it.
So one suggestion might be to wire your event bus up to a collector that could debounce, because I'd imagine a lot of those events are duplicate events. So debouncing those events and just say, if I've got 50, you define a sample rate and say, if I see 50 of these, then I'm going to react. So engines on some sort of intermediary might be a solution to an optimization.
Cool. We got about 5 minutes left.
Okay, so for those of us who don't understand it quite as well, could you just go into engines a little bit more with Salt? How do they plug into the event system? Because when you Google Salt engine, you don't get, SEO-wise, you don't get anywhere. You don't get any information, so thanks.
Yeah, sure thing. The reason that you don't get anything is that code is just going on 36 hours old. Yeah, we will have docs. I promise you that. So basically, engines are, at the end of the day, engines are nothing more than additional long-running processes on a master. Okay, right? The common use case, right, for an additional long-running process on the master is to listen to the master event bus, but it is not limited to that use case. Okay. And so in the typical use case, right, which is, when I say typical, I mean the one we've imagined the most, right, because again, 36 hours old, right, is being able to listen to that event bus, right, and then, write Python that can do, more complex processing than you could do simply with the reactor, right, because right now the reactor basically does nothing more than tag filtering, right, so it's a really simple decision engine, right. So the idea behind Salt engines, right, is that you can sit and you can listen to that event stream and then do whatever you like, right? Whatever you can imagine in Python, you can do. So you can build those types of decision engines to truly suit your use cases, right? Whether, like Corin said, you're deduping on the master side, right, to try and determine trending or what have you, right? Anything that you can do with that event stream that needs to run on the master itself is what engines are designed to accomplish. Right. Yeah. So they're basically, we think of them as the decision engines, right? That perform logic against what's being emitted by beacons, right? In addition to state runs and all the other events that you already see flying around.
So Mike mentioned the first envisioned use case for engines, and I hope that I'm going to have the opportunity to commit the first non-test engine. It's nearly ready to push for a pull request, which actually publishes to the event bus. It reads from SQS and then publishes those messages onto the event bus. And also on the aggregation question, that aggregation could actually be done using minion side engines. If appropriate, depending on whether you're trying to aggregate across minions or from a single minion's events, and then only send events up to the master for evaluation when the minion side engine decides that's necessary.
Yeah, based on Mike's definition of an engine, what's the difference between an engine then and a long-lived runner?
Well, basically an engine stays up as long as the master stays up, right? It's controlled by the master's process manager, right?
Yeah,
Sorry?
I just demoed a runner that did that, and I didn't realize there was a thing called an engine, but it can be as long-lived as you choose to make it.
Right, right.
Okay, so.
Yeah, and we're still fleshing out that model.
Okay.
But yeah, that's fundamentally where it sits right now, and so we're just extending from there. Yeah.
Because I mean, it's just convention that says a runner runs and completes in,
right.
At the command line. Nothing says it has to do that.
Right. The other thing that an engine has is it has the same copy of ops, right, that the master has, right. So it has some sort of insight, right, into the same set of functions and same data that the running master has. But I think that's more of a semantic difference than anything.
Okay.
Yeah.
One last question. All right. Well, thanks everybody for coming out. Thanks, Mike, Matthew, Christian, and Jason.